All right, so for today's lesson, we're talking about area of a circle. So you may be wondering why I've got a whole bunch of shapes up on my board and none of them are circles. Well, the first thing that I want to do is review some of the shapes that we've talked about area for and figure out what all of our formulas have in common. All right, so this first shape, we're going to call this a square. So to find the area of a square, we take the side length times the side length because both of the sides are the same, so we multiply the side times the side. All right, next up, we've got a rectangle. So the area of a rectangle, because all the sides are not the same in a rectangle, unless it's a square, we change from side times side to length times width. All right, then we get to a parallelogram. So with a parallelogram, we have to change it again. We say that the area of a parallelogram is the base, the bottom, times this imaginary line, which we've called the height. Okay, now I've got two different triangles. This first one is a right triangle. So area of a triangle is the base times the height, and then it's half of the original parallelogram. So don't forget we must divide by 2. So same formula over here. The only difference is base is always the bottom. So area equals base times, this is different here. The height is this imaginary line. I'll talk about why that is here in just a second. So base times height divided by 2. So what I want to look at is where we got these formulas from, and then use that idea to figure out how are we going to create the formula for the area of a circle. So if you notice, in a square, side times side, where these two sides meet, I've got this little box. What that box means is that this is a right angle. And this is super important. So area, if you remember, area requires square units. Square units, that's super important. Okay, and area, square units are what we use for area. And we know we have square units when we have this 90-degree angle. So let's look at our rectangle. Area equals length times width. Where the length and width meet, we have a right angle, so we know we have square units. That's why we had to change our formula for a parallelogram. Because in a parallelogram, if we just use the two sides, so we use the base and we use the side, there is not a right angle here, so we are not going to get square units. So instead, we have to use the base and this imaginary line to create a right angle. So we have to use base and the imaginary line called the height to get square units, to get that right angle. Same idea down here. This is a right triangle. So where the base and the other side meet, there is a right angle. So we do get square units. So we take base times height divided by 2. However, with a non-right triangle, our base and the other sides of our triangle do not meet at a right angle. So that's why for a non-right triangle, we've got to use this imaginary line called the height to get that 90-degree angle to get square units. All right, let me clean this up a bit. So now let's look at a circle. Let me try and get a circle up there. Now, we need a 90-degree angle for a circle. That's going to be kind of hard considering by definition a circle has no sides. It's just a constant curve. So I want you to think of parts of a circle that might be able to give us a right angle. So I want you to think about that for a second. Hopefully 2 words came to mind. In a circle, we have 2 features of a circle. One is called the diameter. The other is called the radius. So let's look at both of those for a second. So the diameter is the distance across a circle through its middle. So maybe you thought we could create a square using the diameter. So let's try that. Okay, so I could create a square using the diameter. And if we wanted to cover the surface of that circle, because that's what area is, we would need 2 of those. But hopefully you're noticing that the area of our 2 squares created by our diameter is much, much, much too large. So that's not going to work. So now let's look at the radius. So the radius is half of the diameter. So if I create a square using the radius, I would get a square that looks about that big. Now I want you to take a guess. How many of those squares, how many of this size square is it going to take to cover that circle? So we got 1, 2, 3, and 4. So we just created squares using our radius. This is our radius. So we took radius times radius, radius times radius to get a r squared. Remember, we can show squared units. We can show units of area with that exponent 2. So how many of those did it take? It took 1, 2, 3, 4 of those r squareds to cover the area of our circle. But if you notice, when we used 4 of these r squareds, the area of those squares is bigger than the area of the circle. So 4r squared is too big. So now maybe you think, okay, let's try 3. The problem with 3, if we take these extra little chunks and we put them in this 3rd section of our circle, 3 of those r squareds is too small. Now looking back at that again, hopefully you agree with me that 4 of those r squareds was much too big. 3 of them, if I took these little chunks off and I applied them to this 4 squares, so we'd cover this entire piece, cover this entire piece, cover this entire piece, and those little chunks would almost cover all of our 4th piece. But it's too small, just a little bit. So 3 of those squares is much closer than 4 of those squares. So the exact number of r squareds that it takes to cover the area of a circle is a number we've dealt with in the past, and it's a number we deal with a lot with circles. It is actually pi. Remember that pi is equal to 3.14. So it takes, as we just noticed, a little bit more than 3 of those r squareds, less than 4, and the exact number is pi, 3.14. So to find the area of a circle, we take pi, 3.14, times our r squared times the radius squared. So there's our formula for the area of a circle. And in another video, we're going to look at how to use that to solve area of a circle.